Hello everyone. A solid sphere of radius r and mass m with an initial angular velocity omega naught is placed in the corner formed by the floor and the vertical wall. If the coefficient of sliding friction between all contact surfaces is mu and the sphere never detaches from the ground or the wall, what is the magnitude of its angular acceleration? Before we answer it, let's show the diagram of forces. The first force that we can show here is from the ground, exerting to the center of the mass of this sphere towards downward. This is mg. The other force is normal force in the upward direction. G stands for ground. And the direction of friction can be found if we assume that this contact point is trying to move to the right side. That's why the friction which opposes with the motion will be to the left. F G, right? F ground. And at this contact point, since the sphere tries to move to the left, then we have reaction from the wall to the right side. It's N wall and W. And since, again, like this point, this contact point tries to move downward, friction opposes again to this motion as well, will be in the upward F double. So now we have all forces applying to this sphere from the wall, ground, and now we can write Newton's law to find angular acceleration. So let's start with the horizontal forces. Fg is to the left, so minus Fg. The other force, the other horizontal force is Nw. Nw and Fg are the only two forces in horizontal direction, plus Nw is, since the center of mass of this sphere doesn't translate, that's why there is no any acceleration. I mean translational acceleration. That's why this is 0. Now for vertical forces, we have Fw upward plus Fw and Ng as well plus Ng and Mg downward minus Mg. This is 0, right? We have these two equations. From this equation, we get Fg equals Nw. On the other hand, also we have from friction lecture that Fg is proportional to normal force. So Fg, and the proportionality is coefficient of friction, mu times Ng. So if we substitute instead of Fg, mu and G in this equation, we get Nw equals mu Ng. So this is one equation we found. And also for vertical forces. Again, for Fw, we can substitute mu Nw. The general formula that we have for friction forces, the relation between friction force and normal force, is this, plus Ng equals mg, right? But what is Nw? Nw, we found it here. Therefore, if we use this equation here, we get nu times nu Ng plus Ng equals mg. Therefore, we get, if we factor Ng, this equation, we get Ng 1 plus mu squared equals mg. So Ng, we found Ng as mg over 1 plus mu squared. Since we found Ng like this, therefore we have Nw as well. And Nw as mu mg over 1 plus mu squared. Right? Now let's focus on torque relations. The total torque exerting on this sphere, total torque, general formula, is I times alpha. I is moment of inertia about the central axis, and alpha is angular acceleration. But what are the torques exerting on this sphere? The torques are due to Fg and Fw. So these two forces try to stop the sphere from rotation. That's why we have, because this direction is opposite direction, Fw and Fg apply two torques in opposite direction of rotation. That's why we have minus Fg times arm, which is r, the radius of the sphere, again minus Fw this time, times the arm, which is r, again equals I alpha, right? So we have Fg and Fw. Fg here we said is Nw, and Fw is mu Nw. So if we substitute instead of Fg mu g, let's write instead of Fg this one, Nw minus, instead of Fw we can write mu, this one, sorry, plus mu NW times R equals I alpha. And we can factor out NW 1 plus mu times R equals I alpha. And NW is given by mu mg minus mu g times 1 plus mu R over 1 plus mu squared equals, for I, which is moment of inertia, we have 2 over 5 mr squared. About the axis passes through the center of this sphere, right? So that moment of inertia is given by this formula, and if we substitute it, we get 2 mr squared alpha over 5, right? But here we also have m that we miss it. Now we can cancel out this m by this m and this r by one of the r's here. Ultimately, we get for alpha minus 5 mu g times 1 plus mu over 2r times 1 plus mu squared. And the absolute value of, or the magnitude of, this angular acceleration, this is what we are asked, is 5 mu g times 1 plus mu over 2r 1 plus mu squared. This is the final result for angular magnitude of angular acceleration. But in case someone asks you, how long does it take until this sphere comes to rest? We can find it as well. So to find that time, we can say that when it comes to rest, first of all, the equation is omega minus omega naught equals alpha t, right? When it comes to rest, omega becomes 0 and time becomes minus omega naught over alpha. But remember, t is not negative, t is positive, because alpha is negative, right? The final result will be positive. Therefore, we can write it here, minus omega naught over minus magnitude of alpha, right? And if we cancel out these negative signs, then time becomes 2r omega naught times 1 plus nu squared over 5 nu g times 1 plus nu. This is the time that is required until the sphere comes to rest. Thank you very much for watching this video.